12s, here we have question 7. We need to simplify to a single term. To start off, we are focusing on sine 3x, and we know that we have to compound this. So we're going to write that as sine of 2x plus x. You can actually swap it around. You can say sine of x plus 2x. It doesn't really matter. So I'm just going to go with it like this. Next to that, we have plus sine x, which we cannot simplify any further, so I'm going to leave it like that. Now, in your denominator, you have cos 2x. And I know that when it comes to choosing an expansion for cos 2x, sometimes it's a bit tricky because we have 3 different options. And sometimes you may choose one expansion that doesn't actually work out and give you the answer that you need. So if ever you have cos 2x, what I suggest is leave it as cos 2x and expand it later on when you're able to see something that it could possibly cancel out with from the numerator. Like here, what we notice is that because we have this plus 1 next to it, ideally it would be best if we choose an expansion that has 1 in it as well. Maybe we can go with 2 cos squared x minus 1, then the minus 1 and this plus 1 cancel out. So that's actually the expansion that I would go with, but for now I'm going to leave it as cos 2x until we have simplified the numerator where we can easily see what expansion we should choose. Now remember, in your numerator, you've compounded the sine 3x, and we've got sine 2x plus x. Here, 2x represents A and x represents B. So I'm going to expand this accordingly. So there is my expansion. I have sine 2x cos x plus cos 2x sine x. Now I'm just going to fill in the rest of the fraction where I have the plus sign next to that, and filling in my denominator as well. Now focusing on the expansion that we just filled in, we notice that we have sine 2x. So let's replace sine 2x with its expansion, which is 2 sine x cos x. But next to that, we have cos x. So there it is. And I'm just going to bring down everything else, which is the next 2 terms in the numerator and then our denominator. There we go. So here's something important that you notice about your numerator. They all contain sine x. So I'm actually going to pull that out as a common factor. At the same time, what I want you to notice is that in your first term, if you take out sine x, you are left with 2 cos x times cos x, which we can just write as 2 cos squared x. Taking out sine x from your second term, you're left with cos 2x. And from your third term, you'll just be left with plus 1. I've kept the denominator as is for now. Now the next thing we're going to focus on is how to expand these cos 2x. And looking at what we have in the bracket, since there's a 2 cos squared x plus 1, let's expand it as 2 cos squared x minus 1. And I'm going to do the same thing for the denominator. So here I've highlighted my expansion so you can clearly see what we have. Now what you notice is that your 2 cos squared x plus 2 cos squared x, those are like terms. They're going to add and give us 4 cos squared x. But here we have a minus 1 and then a plus 1. They cancel out. The same thing happens at the bottom where we have minus 1 and plus 1. They cancel out. Now this is what we are left with once we simplify. What we now notice is that we have cos squared in this bracket as well as the denominator. They can cancel out with each other. The 4 and 2 can simplify as well. 4 over 2 is the same thing as 4 divided by 2, which gives us 2. And we're left with sine x. Now we have 2 sine x, and we cannot further simplify from here. So this is our final answer, 2 sine x. So this was a 6-mark question, and here is where your marks were allocated. Firstly, 1 mark for compounding the 3x and 1 mark for its expansion. 1 mark for the expansion of sine 2x. Only 1 mark allocated to the expansion of cos 2x since we used the same expansion for both of it. However, there was a mark allocated to the simplification, and the final mark was for your final answer.